Welcome to the Tech Mechanic. Today's breakdown is part of our Azure Architecture Master Series. If you want the full roadmap, then hit the playlist from the start. With that said, let's dive into today's topic. Imagine your shopping application is running successfully in Azure. Your backups are configured. Your monitoring is working. Everything looks perfect. But suddenly, your entire Azure region becomes unavailable. Your application is down. Customers cannot place orders. And now the question is not, can I restore my data? The question is, how quickly can I bring my application back in another location? That's where Azure Site Recovery comes into the picture. Let's connect this with our previous episode. Azure Backup is primarily about protecting data and creating recovery points. Disaster recovery is broader. It's about getting your application and workloads running again after a major disruption. So remember this simple distinction. Backup helps us recover data. Disaster recovery helps us recover the business service. Azure Site Recovery is Azure's disaster recovery service for orchestrating replication and recovery of supported workloads. The basic idea is straightforward. We have a primary environment. We replicate workloads toward a recovery location. If a disaster occurs, we can initiate a failover. After the primary environment is available again, we can plan for failback. This allows us to design a structured disaster recovery process instead of manually rebuilding everything during an emergency. Remember RPO and RTO from our Azure Backup episode? They become even more important here. RPO asks, how much data can we afford to lose? RTO asks, how quickly must the application be available again? Suppose the business says, our RPO is 15 minutes and our RTO is 1 hour. That immediately influences our disaster recovery architecture. These are business requirements first, and technology decisions second. A typical disaster recovery architecture uses a primary region and a separate recovery region. The primary region handles normal production traffic. The recovery region is designed to take over when required. But notice something important. The recovery region isn't simply a copy sitting there without a plan. We need replication, networking, dependencies, DNS or traffic routing, security and a tested failover process. That's where architecture becomes critical. During normal operation, users access the primary environment. If a disaster occurs, we initiate a failover. The recovery environment becomes the active environment. Traffic is then redirected toward the recovered application. The exact traffic routing mechanism depends on the overall architecture. The important point is that failover should be planned, automated where appropriate, and tested regularly. Disaster recovery isn't simply pressing a failover button. A recovery plan defines what happens during the incident. We detect the problem. We determine whether failover is required. We initiate recovery. We validate the recovered environment. We redirect traffic. And finally, we monitor the recovered system. A good disaster recovery design turns chaos into a repeatable process. Azure Site Recovery uses a recovery services vault as part of its configuration and management experience. The vault becomes a central place for managing recovery configuration and related operations. You'll notice the same vault concept from Azure Backup. But don't confuse the services. Azure Backup and Azure Site Recovery solve different recovery problems. Backup focuses on recovery points and data protection. Site Recovery focuses on orchestrating disaster recovery and failover. Now let's move into the Azure portal. I'll open our Recovery Services vault. From the vault, we can access the site recovery experience. This is where we can configure and manage disaster recovery for supported workloads. To get started, Log into your Azure portal and search for Recovery Services Vaults. Create a new vault. Give it a name like Azure Resource Vault, and place it in your target disaster recovery region like South India. Once your vault is deployed, look under the Getting Started section on the left-hand menu and click on Site Recovery. From here, click Prepare Infrastructure to configure your source environment, whether that's Azure VMs, VMware, or Hyper-V, and pair it with a replication policy to define your RPO. Once replication is live, your Vault Overview page acts as your central disaster recovery command center. Let's break down what this screen tells you. Top Overview 1, 4 and 7. The top bar lets you quickly toggle between backup and site recovery metrics. To the right, you can instantly see active configuration warnings, like subscription quota limits, and check your total number of automated recovery plans. Health and Readiness 2 and 3. The left donut charts give you a real-time health check. They show you exactly how many virtual machines are healthy and track your drilling history to ensure your last failover tests were successful. Infrastructure and Issues 5, 6 and 8. The bottom half visualize your entire data pipeline from source servers into Azure storage. Surrounding logs track your active errors and provide a 24-hour summary of all background replication jobs. If you are looking at a brand new vault like this second environment, your dashboard will look empty with zeros across the board. To move past this screen and populate your dashboard, look closely at the center of the visual map and click the link that says, Learn More, to start replicating your very first virtual machines between Azure regions. Now here's an important concept for architects, the recovery plan. Real applications aren't a single VM. They have dependencies. Maybe the database needs to start first, then the backend, then the API, and finally the front end. A recovery plan helps us organize the recovery sequence. That's extremely important because simply starting every component randomly doesn't guarantee that the application will work. One of the most important practices in disaster recovery is testing. We don't want to discover during a real disaster that our recovery process doesn't work. That's why organizations should perform planned disaster recovery tests. We validate the recovered environment, application dependencies, and connectivity. And after testing, we clean up the temporary recovery resources according to the chosen test process. A disaster recovery plan that has never been tested is only an assumption. Now let's introduce two important terms. Failover means moving the workload from the primary environment toward the recovery environment. Failback is the process of returning operations toward the primary environment after the original environment has been recovered and the organization is ready. So disaster recovery isn't just move to DR. We also need a strategy for returning to normal operations. Now let's look at the bigger solution architect picture. We have our primary region. We have our recovery region. Workloads are replicated according to the disaster recovery design. Site recovery helps orchestrate recovery. Traffic management redirects users toward the appropriate environment. But remember, site recovery is only one part of the architecture. Networking, identity, databases, DNS, secrets, external dependencies and application configuration must all be included in the disaster recovery design. Let's finish with an architect challenge. Your primary Azure region is unavailable. The business tells you, RPO, 15 minutes. RTO, 1 hour. What would your disaster recovery architecture look like? Would you simply restore yesterday's backup? Probably not. You need a recovery strategy designed around the business objectives. Replication, recovery environment, recovery plan, testing, failover, traffic redirection, and continuous monitoring. And here's the key lesson. Disaster recovery isn't about having another region. It's about being able to reliably operate from that region when the business needs it. Whether your goal is to become a solution architect, cloud architect, AI architect, or simply a better software engineer, the Tech Mechanic is your learning destination. Like this video, subscribe, and hit the bell icon to stay ahead in your tech journey.